So in this lesson, we're going to look at a bit of trigonometry. I'm going to first teach you how to find a missing side of a triangle, and then I'm going to show you how to find a missing angle. And just to cover some of the basics of trigonometry. So trigonometry, much like Pythagoras' theorem, which is something that overlaps into the topic, only applies to right-angled triangles. So we're going to be dealing with right-angled triangles. A wee recap of something that you probably learnt in class is your trig functions, sine, cos and tan, and the equations to go with them. Before we go any further with examples and trying to find missing sides or angles, I will show you how to identify the sides within a right-angled triangle. The phrase so ca toa, which again you've probably heard before, is a way that it's a short phrase that we use to remember the three different trig functions and their associated formula. So sine vita, in any of these is the angle that we're working with, or potentially the angle that we're trying to find, depending on whether it's a missing side or a missing angle question. So sine vita equals the opposite side over the hypotenuse. So opposite, hypotenuse and adjacent are the three sides. So SOH is how we remember sine vita equals opposite over hypotenuse, S, O and H. Ca for CA and H, so cos vita, again the angle that we're working with or trying to find, equals adjacent over hypotenuse, so that's the adjacent side over the hypotenuse. So the last one then being TOA, so TOA, tan vita equals the opposite side over the adjacent side, so TOA. So that is how we remember the three different formula, so, ca, toa, sine, cos and tan, and their three associated formula. So what I very briefly show you is how to do here, and again it's just covering some of the basics before we get stuck into some questions on finding the missing side, is how we identify the sides within a right angled triangle. So firstly, as you can see, I've got couple of roughly drawn right angled triangles on the board, and we're going to label the three sides within each. So you may remember this from Pythagoras' theorem as well. How we label the hypotenuse. The hypotenuse of any right angled triangle is the longest side, and the way to identify it is that it's always opposite the right angle. So the right angle will always clearly be marked, and it's the way I would think about it is the right angle is kind of like an arrow. That corner of the right angle is like an arrow pointing to it and saying this is the hypotenuse. Okay, so in this particular triangle, this first one, that is the hypotenuse. We're now going to look at, and this is where the angle vita is going to come into play, how we identify the opposite and adjacent. So the opposite kind of speaks for itself. The opposite side is the side that is opposite the angle that we are working with or trying to find the angle vita. So in this case, that is the side opposite to the angle, so that is the opposite. Okay, and I mean, if we've already labelled hypotenuse and opposite in this triangle, I mean the remaining one is of course going to be our adjacent, but just to explain what that means, adjacent, if something is adjacent to something that runs alongside it, so this side is adjacent to the angle that we're working with, so that is the adjacent. And that can change, these three sides, well the hypotenuse will always remain the same, but opposite and adjacent may change depending on the orientation or the angle that you're looking at. So if I was to look at this second triangle and identify the three sides, well, hypotenuse opposite the right angle, so this is the hypotenuse, our longest side. This is the angle that we're working with down here, so opposite side is this one over here, and the adjacent in this case is the bottom side. So now being able to label three sides, the three sides within a right angled triangle, we're going to look at some questions on how to find the missing length of a side in a right angled triangle. So this is our first example in trying to find a missing side in a right angled triangle using trigonometry. So we have enough information here to find the side. There's a couple of steps with any trig question, and the first one is to, I'll write the steps up here, is to identify the sides we're working with. You don't necessarily need to identify all three sides, but you need to identify the sides we're working with. And the reason we do that is because the sides that we're working with, the sides that we're using, and what I mean by working with, I mean we don't know we only know one side. We're working with this side and this side. So the side we're working with is also the side we're trying to find. So we need to identify the side that we know and the side we're trying to find, and that's going to help us to choose the correct trig function. So if we think back to whenever we were identifying the sides, so opposite the right angle, that is the hypotenuse. So I'm just going to write the letter for short. So that is H, okay? That is the hypotenuse. The side that we're trying to find is opposite the angle that we know. The angle that we know in these types of equations is within the formula, that is beta. So this angle 32, that is going to be within the formula that we use later, that is the angle beta. So this side is opposite to that angle, so it is the opposite. So, and again, this is also the reason we don't need to label this bottom side, is because we don't actually need it when we're not using it. And if I consider that I'm using opposite and hypotenuse, so just going to refer back to SOHCAHTOA. Okay, if I'm using and I'm working with opposite and hypotenuse, which one of these, so, cat, or toa, contains O and H, opposite and hypotenuse? Well, it's this one. So this is sine beta equals opposite over hypotenuse. So that is the second step, is to then, once we've identified the sides, is to choose the correct trig function. And we do that by using the sides we've identified. So we choose trig function. Okay, so once we've done that, sine beta equals opposite over hypotenuse. We're using sine in this case. It's just a matter of substitution, so substitute known values. Okay, so let's take our known values from the diagram of the triangle. So beta is the angle, so sine beta becomes sine. In this case, beta, the angle is 32, is equal to the opposite over hypotenuse. So the opposite is x, which we're trying to find, so we can either just leave it as opposite or write in x, which is what we're trying to find, over the hypotenuse. The hypotenuse is 7. So we have enough information within this formula to now work it out. I want to get x on its own. We're just solving an equation now. So if I want to get x on its own, the 7 is dividing. So what I'm essentially doing is I'm going to multiply by 7 to get rid of the 7 over here. So what this becomes on the left hand side is 7 times sine 32. Okay, is equal to x. So we're essentially moving the 7 across and becomes 7 times sine 32. Now this is where we now use our calculator. Make sure the calculator is set in degrees. In terms of a calculator, I would always advise you with a scientific one. The Casio models, this type of model, are the best. Put it into your calculator. So 7 sine 32, making sure the calculator is in degrees. And that gives me 3.709. It gives me a big long decimal number. Now, within a question in your exam, also it will tell you to round to a suitable degree of accuracy. For the sake of this example, to speed things up, I haven't, but I'm just going to round it to 1 decimal place. So my answer is 3.7. And where appropriate as well, we've just found out the length of a side. So if this is in centimetres, this is also in centimetres. So just be careful of that, because you'll know from any questions that involves geometry, whether it's perimeter, area, or stuff like that, there can be a mark awarded for making sure your units are included. So just make sure the 1 decimal place, that is 3.7 centimetres. And that is our first example. So on our second example, pretty much the exact same thing. First thing we're going to do is we're going to identify the sides that we're working with. So we've got the side labelled x and the side that we know is 9 centimetres. Okay, so the side that is 9 centimetres is the side that is opposite the hypotenuse, or opposite the right angle, so therefore it is the hypotenuse. Okay, this side that is labelled x, this is where the angle that we know comes into play. This is our angle beta within whatever equation we're going to be using. It runs alongside the angle, so therefore it is the adjacent. So this time we're using adjacent and hypotenuse. So again, let's just refer to SOHCAHTOA. Which one contains A and H? Okay, because A and H is what we're using, adjacent and hypotenuse. So that's O and H, this is A and H. So just remember that is cos beta equals A over H, adjacent over hypotenuse. So now we've chosen our trig function, we're going to substitute our known values in. So cos theta becomes cos 40, which equals A. A is the side that we're trying to find, which is X, over H, which is 9 centimeters, okay? So again, now we're just going to manipulate, change the equation a wee bit. So the 9 on the right is dividing, so we'll move it across, become multiply, so it becomes 9 times cos 40 equals X. We're going to put that into your calculator and again round on this occasion to 1 decimal place. And always just check, it mightn't be the case with whatever question you're doing. It might say significant figures. Decimal places, always check what they're asking you to round to. So 9 cos 40 equals 6.9 to 1 decimal place. So, and again, we're dealing with centimeters, so 6.9 centimeters. Make sure we get that in to get that mark for our units. Okay, so now on to our third example of finding a missing side. So again, starting off, same thing, we label the sides that we're working with. So we're not using the hypotenuse in this case. There's the longest side opposite the right angle, so it's not labelled and it's not something we're trying to find, so we're not using the hypotenuse. The side that's labelled 3 is opposite the angle theta that we're using, so 21 is theta, so therefore the 3 is our opposite side. This side that's labelled X runs alongside the angle theta, so therefore it is our adjacent side. So we're using opposite and adjacent. So back to using SOHCAHTOA to decide what trig function, so which one contains O and A. So that's O and H, that's A and H, there's O and A. So we're using tan this time, so it's tan theta equals opposite over adjacent. Okay, so let's substitute in our values. And there's a wee added thing to this, I just want to take a wee minute to point out these. Tan theta equals opposite over adjacent. When we substitute in our known values, so theta is 21, so we're doing tan 21 equals 3 over A, which is X, the side we're trying to find. What you'll just notice here, and I want you to keep an eye out for this if this ever occurs, is that in the first two examples, you'll have noticed the X, the side that we're trying to find, was on the top line of the fraction. In this case, it's on the bottom line. And when this happens, this becomes a dividing question, because what you end up doing is moving the X to the left and the tan 21 moves to the right to become a divide. So what you end up with is you basically swap these two. So again, we're going to end up with X equals 3 divided by tan 21. And you can type that into your calculator as 3 divided by 21 or 3 over 21 as a fraction. And again, that's the handy thing about the Casio makeup calculators. You can use the fraction button and type it in exactly as I've written it here. So 3 over tan 21 gives me 7.8 to 1 decimal place. And again, our units being centimeters. So just to point out, just to keep an eye out, if the X is on the bottom, it's a division like this. So in the next two examples, we're going to look at how we find missing angles. So most of the steps are pretty much identical when we're trying to find a missing angle within a right angle triangle. There's just a couple of wee different things that we're going to encounter. We're going to encounter our inverse trig functions. Okay, and I'll show you how to use those as we come across them. So, I mean, the first step is pretty much the same. Label the sides you're working with, okay? So in this case, they have to give you at least 2 sides, so label known sides. So, as you can see on the diagram, I have 2 sides that I've been given. I've got this one that's 9 centimeters and this one that is 4 centimeters. So the one that is 9 is opposite the right angle, so that is my hypotenuse, okay? This one that is theta is opposite the angle theta that we're trying to find. So that is my opposite. So I'm dealing with opposite and hypotenuse. And again, think of SOHCAHTOA, opposite and hypotenuse, we're dealing with sine. So again, the second step, nothing's changed. We choose our trig function. So we know the trig function is sine. So we write out our formula. sine beta equals opposite over hypotenuse. Everything so far exactly the same as when we were finding the missing side. We substitute in our known values. So beta is what we're trying to find. So sine beta remains as sine beta, or whatever they've called this angle. They may call it x, they may call it a, they may call it anything they want. So sine beta, beta being what we're trying to find, is equal to opposite over hypotenuse, which is now 4 over 9. Now, here's where it's different. We're going to use the inverse trig function. So we have 3 inverse trig functions. There's 3 trig functions, so therefore there's 3 inverse functions. So the opposite to sine, we want to get beta on its own, so the opposite to sine is sine to the minus 1. So the inverse function of sine is sine to the minus 1. And of course the other 2 being, I'll put them up here, although we're not using them just yet, is cos to the minus 1 and tan to the minus 1. Okay, so that's what we're doing. We're moving this sine to the right hand side. So beta equals, when sine moves across, it becomes sine to the minus 1 of the fraction that we already have there of 4 over 9. And that's what we're going to put in to the calculator in a wee second. So just to explain to you, and I mean, how you would get it up on a Casio or most calculators. If I want to get sine to the minus 1, I need to use the shift function on my calculator. So on my calculator, it's the very, very top left button up here. So I push this first, and I see a little S appearing on the top of the monitor, and then I hit sine, and that gives me sine to the minus 1. So your calculator might be slightly different, just take a wee opportunity to have a look at it. So I'm doing sine to the minus 1 of 4 over 9, and again, because Casio has a fraction button on it, I can just type that in as 4 over 9. And I close my bracket, sine to the minus 1 of 4 over 9 is equal to 26.4 to 1 decimal place. And remember, this time we're finding an angle, so this is in degrees. So 26.4 degrees. Okay? So this is our second example of how to find a missing angle, and what you'll discover is that there's very, very little different. Once you know how to do the one, you can do them all. Start off, like in any trig question, labeling the sides that we're working with. So I have the side that is known as 5 and 6 centimeters. So this side, 5 centimeters, is opposite the angle beta that we're trying to find, so therefore it is the opposite side. The side that is 6 is the one that runs alongside beta, is therefore the adjacent. I mean, I would know that's the hypotenuse, that's because it's opposite the right angle, but I'm not using it, I don't know it, and I'm not trying to find it. So I'm working with opposite and adjacent. So if I think of SOCAD TOA, TOA containing O and A, I'm using tan. So tan beta equals opposite over adjacent. Again, at this point we now substitute in the values that we know. So tan beta remains as tan beta because beta is what we're trying to find, is equal to the opposite side, which is 5, over the adjacent, which is 6. And now, again, this is where our angle questions are a wee bit different. We don't want tan beta, we just want beta. So we're going to move that tan across to the left, to the right hand side. So it's going to become an inverse tan. So it becomes tan to the minus 1 of the fraction on the right, which was 5 over 6. Okay, and again, just to explain how you get the inverse function, shift tan to the minus 1, and I'll use my fraction button on my calculator of 5 over 6, close my bracket, which in this case gives me an angle of 39.8 degrees. Okay, so 39.8 degrees, and that is to 1 decimal place. Now there are other types of questions asked on trigonometry set in certain contexts, such as a ladder against a wall, or perhaps using an XY axis where you have to find the length of a line that can also contain Pythagoras, but the method is the same as anything you've just saw here so far.